Let's take a look at number 19, enums and switch. All right, multiple choice. A lot of times we got to make choices. Many times we just pick from one set of options. So for example, we have a school lunch. You've got pasta, burger, or soup, and they're really not going to give you any other choices. You can't combine them. You just got to pick one. So this is something that works well, of course, for school because they only got to provide one of three. They can not waste any time and make it as boring for everyone as possible. So now let's figure out how we can apply this to programming. Let's go to Make Decisions Revisited. So we've seen this before where we could create a function, and within there we can do if and return and go else if or else to give us these three options. So for example, cook lunch. Now the question is, let's try some different choices to see what happens. All right, let's cook some lunch. What I really want is, guess, I want pizza and soup. Oh man, I don't want soup. All right, cook lunch. How about a burger? Let's go with the burger. Hey, I got a burger. All right, what else? Let's try tofu. Get some vegetarian stuff. Hey, I got soup. That's not what I wanted. All right, now as you can see, you can only get one of these others. If you ask for something else, all you get is soup. And there's nothing that tells you what you can ask for. And if you don't know what's in the function, you can't. All you know is it takes a string. You won't know what it would expect. So the best way to do that, let's look at enumerations. So an enumeration is a group of related choices, and each choice is called a case. So this is how it's defined. You have enum is the keyword, then you have the type, and you say case, pasta, burger, and soup. So here this is a new type. Notice we often will call this an enum. In general, we're just going to refer to this as an enum. The type of it starts with a capital letter, and then each case starts with lowercase. Notice here, this is a very key point. It says the enum should be singular, as in lunch choice, not lunch choices, because the value refers to only one choice, not many choices. Okay, so here's how you would call that. Now, the good thing is it limits to specific cases, and you can't do anything that's not listed. So if I uncomment this, well, guess what? It throws an error because fish is not a lunch option. Got to go to a different school. Okay, create some constants and let's check it out. Now let's say let burger equal lunch choice dot burger, and what else? Let soup equal lunch choice, and again notice autocomplete tells you all the available options. Pretty cool. And we want soup. All right, let's go to the next, enums and type inference. So we can save a lot of time and save a lot of typing when we use enums. So here you can also write enums this way, where you list keyword as case, and then you list pasta, and then all the others followed with a comma. So if you have multiple choices, you can just list them all in one line. Saves a little space. Now, we talked about creating a constant, but you can also create a variable. Now, when you do this, Swift already knows what to expect, so we don't have to write the enum name again. So check this out. We've created a variable of lunch, which is of type lunch choice. Then when we assign it, all we have to use is the dot, because it is of type lunch choice. So we don't have to write lunch choice dot burger, which is great. So that has a lot of shorthand. So let's try some other things. Let's assign choice to finally, I guess I'll have the soup. And then what else? Might as well have the pasta. Okay. Let's go to when to use enums. So when you have a restricted group of related values, it's a good idea to use an enum. Now, there's not really any restriction on it, but if you have a large possible number of values, enums probably won't be the best fit. So let's go to an example. If we're writing a sports game, we have a struct that represents each player, and you've got player properties. You've got a name, skill level, team, and position. Name is a string. You wouldn't use an enum because there's no way to know all the names. Skill level would be an int, since you're using points. Team would be an enum because there's only two teams on the field. We got red and blue. Position would also be an enum. You've got quarterback, seeker, pitcher, so on, depending on how you design the game. All right, let's define enums to represent the team and position options. So we will start with enum. We're going to say team, capital T, team choice. And we're going to say case red, comma, blue. All right. And for position, we're going to say enum position choice. And let's say case we have quarterback, seeker, pitcher, and whatever. I don't know what this game is, but why don't we have the seeker, the pitcher? I don't know. What is this? A game of snitch? I forget all the titles. It's been a while. All right. Very good. So there are the enums. Let's go to comparing enums. So making decisions with enums, you have to be able to compare one value to another. So we've already got this lunch choice enum. Now you can compare them using the is equal to or double equals. It's same if it was a string or an int. So for example, you have two constants. One's my lunch, lunch choice.burger, your lunch choice.burger. If my lunch is equal to your lunch, hey, we're having the same lunch. Else, can I try your lunch? So change my lunch to a different choice to see a different value in the results. All right, well, let's go with pasta. And what happens? Hey, can I try your lunch? Okay, let's improve this. Enums and functions. So enum values can be used as a parameter or return values for functions, just like any other type. Here we've got our lunch choice. You could rewrite the cook lunch function from earlier. So we go through here and we say if choice is equal to dot pasta. Notice here how this works. There's this variable that is of type lunch choice. So now we have the abbreviated. Remember, we don't have to type the whole thing. We have the dot pasta. Else if choice is equal to burger, return burger, else. And let's see how that goes. Let's say cook lunch, and hold on. What's going on here? Let's hold it together, people. Choice. All right, hold on. Let's back up. See what's going on. Cook lunch choice, and we're going to say dot soup. All right. What do I get? What do I get for soup? There we go. Good job. Give me my soup. Notice because it was expecting a type, I could, as soon as I press the dot, it then gave me autocomplete, and so now I can say burger. Now, notice because we have the enum, we know exactly what's there. We'll always choose something that's available. So, like I said, autocomplete tells us you can't pass anything else, so you'll always get what you passed in. So let's go next. The problem with if. An if statement's useful for checking single conditions, but If statement's used when you have multiple if else, it gets a little too much. So this is an animation. Notice how says the animation highlights a problem with the if. The last choice really isn't anything else. It's just soup. So if you're reading this code without knowing the last case, you'd have to guess because it doesn't tell us what the case is. So rewriting the function, we can say here else if return. How did we get here? You still need a final return statement, but the problem is you'll never reach that because you're using an enum. You will always pass in one of these three options, and so these will be called, but this last return will never be called. So here the trouble is you have to have the last return. Let's comment it out, see what happens. The problem is missing return expected return string because you have to have that default in there. So that's not the best solution. Well, let's go to switch. So we know ifs aren't the best. There's a better way. It's called a switch statement. So notice you start with the keyword switch and then you have the value that you are checking against. In this case, it is a variable choice, which is of type lunch choice, right? Then we have case and we have dot pasta and we've got a colon and then a value, burger and soup. So because the variable, we know what the type is, we can abbreviate by using the dot and then the value. We don't have to write out lunch choice dot pasta, things like that. So this is identical to doing a bunch of if statements, but it's much cleaner and it is much more efficient because you're only using the cases that are needed. Now, let's go on to find out some other features. Switch statements have a special feature. They must be exhaustive. This means a switch statement must exhaust every possibility of the value being checked. With an enum, you can use a different case to handle every possible value. So for enums, that works really well because you have every choice made available. Now, add another case, taco. What happens to the switch statement? Let's see what happens. Case taco. Uh-oh, we get an error because switch must be exhaustive. Consider adding a default clause. So we fix the error by adding another case, and we can use, so we say case dot taco, and let's use the control command space to bring up the good old emojis and food and taco. Awesome. There it is. Now the error went away. Perfect. So the reason, because switch statements must be exhaustive, then you'll always make sure that you're not missing anything, which is really good. Works great with enums. Now, what about this idea of a default case? So here's an enum. We've got quality, bad, poor, acceptable, good, great. The switch statement is a little different here. We have case bad, case poor, and then default. Okay, I'll take it. So this switch statement doesn't have a case for everything. Instead, it uses a default, and the default captures everything else. So if we change quality, so here, change the value of quality to test whether the default case is used and when specific cases are used. Try adding more cases to the switch statement. Notice the default case has to be the last case. So quality. Let's see what happens. Let's go with acceptable. And what does it say? Okay, I'll take it. What about poor? What happens when I change that to poor? It's not good enough. Okay, try adding more cases. So let's say case, and we're going to say dot acceptable, and then a colon. We're going to say anything better? All right, now let's check out, let's change there, let's see how that looks. Acceptable. Anything better? All right, see how that works? Now if you add more cases to the enum, let's go with amazing. And remember, because we use default, the switch case, this particular switch is exhaustive, because if it's not specifically .bad or .poor or .acceptable, everything else will fall under default. All right, let's go to multiple cases. So we've talked about default case. We have quality, bad, poor, acceptable, good, great. But a default case might cause a problem if you add new cases. The switch statement will use the default case for your new value, which is maybe you don't want that. Instead, you can match several values in the same case. Check this out. So here you have a case for .bad and a case for .poor, and then you can say .acceptable, .good, .great. All right, let's add a new case, terrible. What do you think is going to happen? Well, guess what? Because I have an extra case in there, check it out. We get an error because it's not exhaustive. So what else happens is I can go ahead and just add that, and I'll say terrible, and watch what happens. The error goes away because we can use multiple cases in our switch statement. Perfect. All right, more than enums. So we've talked about enums and how to use switch statements. You can also use switch statements with other values. So for example, we have a constant here, animal, which is of type string, and we say sound for, and we pass in an animal, which is string, and then we switch against this variable, and we say case cat, meow, all this stuff. So see how that works? We're not using an enum, but we're using a variable. And so when you use a case, you're using the value which matches the type of this. So this is a string type, so we're going to use a string to compare it against. So this is asking the question, hey, if animal is equal to cat, return meow, or dog, or cow, or chicken. Awesome. So let's pass in some known and unknown. Sound for cat. Let's see what we get for sound for cat. What about sound for chicken? And I asked this in a previous video, but the question is, what does the fox say? I don't know. Somebody knows. Somebody knows what I'm talking about. All right, let's go back to the cafeteria. So switch statements work really well with enums. It says they must be exhaustive. You can be sure you're dealing with all the possibilities. Here's the cook lunch function, where here we're exhausting all the possibilities. Now, this is a lot better because we've cleaned it up. We're using an enum and a switch statement covering all the cases. Now, notice here inside the function, the flow of the program is obvious and there's no need for any just in case because we know exactly we're covering everything that's possible. And if we change the definition, the program won't run until we update the switch statement. Now let's talk about enums, methods, and properties. When we talked about structures, we talked about properties and methods. You can also define those same thing in an enum. So, for example, we can say here we have lunch choice and we have our case, pasta, burger, soup, and check this out. We have a variable for emoji and we're using a switch statement that returns, depending on the case that's selected, it returns the value. Check this out. Lunch choice equals dot pasta, lunch dot emoji, and there it is. Pretty cool. Now, there's something called the self keyword, and this is used in methods and calculator properties to refer to instances of itself that are being asked for. So here, right here, switch, and it's saying self. It's referring to its own, the enum there. So that's why you can do the abbreviated enum, because it's referring to self, which is of type lunch choice. Makes sense? You could have a method that compares two enums. For example, in a card game, you could have something that returns a value like rank. And then finally, here's this function which calculates whether one beats another. And you say if rank is higher than other suit.rank, then it wins. So this is how it's being used. We got one instance is suit.spades, another instance is suit.clubs, and then we say one suit.beats other suit, and that returns true. One suit beats one suit, and that returns false. Add a suit property to the suit enum that returns the appropriate emoji for each case. Ooh, okay, so remember how we did this up before? We said var emoji, which is of type string, and we're going to say switch self, which is a suit, and the case is going to be case dot spades, and then return, and this is a string, so press Control Command space, and where are I don't know my emojis. Where's the fancy ones? Oh no, I'm gonna have to search here. Hold on. Yell it out if you see it. Someone's like, Brent, don't you know what it is? Come on. And I'm like, nope. And then someone's like, well, Brent, what if you just copy and paste? And I'm like, oh yeah, we can copy. There it is. Found it. Okay. Spade. Awesome. Now we do another case. Dot hearts. Return. I'm adding the quotes, and then I'm gonna figure out the text. And we go hearts. And then we say case dot diamonds. Return. And we say diamonds. And finally, case dot clubs. Return. Clubs. Cool. Check that out. All right. So we've talked about enumerations when you want to represent a group of related values, and those values are called a case. It's very similar to you're creating a new type, and so the type will only have values that match one of the cases. It makes your code a lot easier to write and clearer of what the possible values are. You can compare enums with equals equals or using a switch statement. So switch statements are another way of making decisions, and they work very well with enums. Switch statements must be exhaustive, so you have to handle all the possible cases. You can also use what they call the default case. And like structs, you can add calculated properties and methods to enums. All right, thanks for watching. Be sure to subscribe and look for the next video where we will review the exercises.